In this video, we're going to learn how to solve an equation with two radicals. Now, the process of going about doing this is to isolate one of the radicals first. Usually I go with one that maybe looks more complicated, or I just make sure all the radicals are positive to begin with. So you see that we're subtracting here. I'll just add the square root of x to the right to start. By doing so, I'll have the square root of 2x plus 1 is equal to the square root of x plus 1. Now with this, I will square each side of my equation. Now this won't necessarily get rid of the square root on the right side, but it'll get rid of the one on the left. And I've already reduced the number of radicals in my equation by 1. So I'll have 2x plus 1 is equal to the square root of x plus 1 times the square root of x plus 1. So doing that, I'll do my first will be square root of x times the square root of x, and I'll show this on the side here. Square root of x times the square root of x, which is x. The square root of x times 1, which is the square root of x. 1 times the square root of x, which is also the square root of x. And 1 times 1, which is 1. Now, I'll isolate this radical on the right side. I can combine these like terms and subtract 1 and x to leave me with just an x on the left side. So I'll have x is equal to 2 square roots of x. And then to eliminate that radical, I'll square each side again to give me x squared is equal to 2 squared, which is 4 times x. Now I have a quadratic, so I can move everything to one side and factor out an x to solve. So my two possible solutions are x is equal to 0 and 4. X is equal to 4. Now, checking for my extraneous solutions, because again, I changed my radical equation to a quadratic. So I definitely could have implemented a new solution on accident. So checking, if I plug in 0, I'll get the square root of 2 times 0 plus 1, which is 1, minus the square root of 0, which should equal 1, so that works. And then for my next one, I'm going to check the square root of 2 times 4 plus 1, which is 9, minus the square root of 4, which would be 3 minus 2, which is also 1. That also works. So both solutions work. Let's try that one more time, and then I'll go into some other situations. So we want to isolate that radical. So I'll add the square root of x to each side. So I'll have the square root of 5x plus 4 equals the square root of x plus 4. I'll square each side of my equation. So on the left side I have 5x plus 4, but on the right side I'll have to do the square root of x plus 4 times itself, which leaves me with the square root of x times the square root of x, which is x, then 4 square roots of x plus 4 square roots of x, which is 8 square roots of x, and then 4 times 4, which is 16. Now I'll isolate this radical by subtracting x and subtracting 16, giving me 4x minus 12 equals 8 square roots of x. Now see here, there's a common factor of 4, so I'm going to divide each side of my equation by 4, just to make the numbers smaller. So we'll have x minus 3 is equal to 2 square roots of x, and then we'll square each side as well. Now that binomial on the left, which expands to be x squared minus 6x plus 9, is equal to 2 squared, which is 4 times x. I'll subtract x, and I'll have x squared minus 10x plus 9 equals 0, which when factored gives me x minus 1 times x minus 9 equals 0. So my two solutions are 1 and 9. Now you do want to test both of these solutions to make sure they work. So a quick check. Plug it in 1, you'll have 5 times 1 plus 4, which is the square root of 9, minus the square root of 1, which would be 3 minus 1, which is not 4. 3 minus 1 is 2, which does not equal 4. So that's not a solution. Plug in a 9, you get 5 times 9, which is 45. Plus 4 is 49. So we'll plug in a 9. I'll have square root of 49 minus the square root of 9, which is 7 minus 3, which is equal to 4. So the only solution is 9. 1 was extraneous. Now, to solve this equation up here, we have two different types of radicals. So I'm going to separate them by adding 5 minus 2x to the 1/4 to each side of the equation. So I'll have x plus 5 to the 1/2 equals 5 minus 2x to the 1/4. Now, to eliminate the radical, I could eliminate either one first. Now, I could multiply each side by 2, but it still keeps a fraction on my right side. But if I raise each side to the 4th power and not the second, then I'll have 1/2 times 4, which gets rid of that radical, and get rid of this radical. So I'm going to raise each side to the 4th power to eliminate both radicals at the same time, because there are no other terms, like you saw earlier, like this plus 1 and this plus 4. So I can pull this off. So on the left, I have x plus 5 squared, which is always positive. And on the right, 1/4 and 4 are reciprocals. So I'll end up with just 5 minus 2x. But since I raised it to the 4th power, that makes it positive. I have to use absolute value. Now I'll expand this expression on the left to be x squared plus 10x plus 25 equals absolute value of 5 minus 2x. So this can equal the positive or negative of this side. So one possible equation I need to solve is positive x squared plus 10x plus 25, which is equal to 5 minus 2x. Or I have to solve negative x squared minus 10x minus 25 is equal to 5 minus 2x, which is the negative of that expression. Now, moving everything to one side in both equations, I'll have x squared plus 12x plus 20 is equal to 0. And on the right side, I'll have 0 is equal to x squared plus 8x plus 30. On the left side, this can be factored, I believe, into x plus 2 times x plus 10, which gives me the solutions negative 2 and negative 10. And on the right side, this cannot be factored. I can't multiply to 30 and add to 8. So I'm going to use complete the square to solve this one. So I need to add half of 8 squared, which is 16 to both sides. That creates a perfect square trinomial, giving me negative 14 is equal to x plus 4 squared. But when I go to take the square roots, these will be imaginary solutions. So I'm going to stop my solving process there, and these solutions will not be used for my final solution. But just to write them out, so you can see what the answer is, I would have the absolute value of x plus 4 is equal to I square roots of 14. So x would equal plus or negative 4 when I subtract negative 4 plus or minus I square roots of 14. It's unfortunate we won't be able to use these solutions since we wouldn't be able to plug them in and check them. But now to check to see if negative 2 or negative 10 works, checking negative 2 first, I have negative 2 plus 5 to the 1/2 minus 5 minus 2 times negative 2 to the 1/4. Oop, ran out of room. I'll fix that in the next step. I'll have 3 to the 1/2 minus 5 plus 4, which would be 9 to the 1/4. And I want this to equal 0 for it to be correct. 9 is also known as 3 squared. So you have 3 to the 1/2 minus 3 squared to the 1/4, which gives you 3 to the 1/2 minus 3 to the 1/2, which is 0. So negative 2 definitely works as a solution. And then we'll check negative 10 as well. Don't put right above the equation because I'm running out of space in this little box. This one would be negative 10 plus 5, which will be negative 5 to the 1/2, minus 15 plus 20 to the 1/4. And I'm already noticing this will be an imaginary number minus a real number. So there's no way for that to actually equal 0. So 10 cannot work. So my only solution is negative 2. So for my last equation, I have a binomial underneath the radical. I'm about to move to the other side. So both of them have binomials in them, unlike the other two on the left. So first I'll add the square root of x minus 1 to both sides of the equation. Give me the square root of 2x plus 6 is equal to the square root of x minus 1 plus 2. I'll square each side of my equation. On the right side, I'll do the square root of x minus 1 plus 2 times itself. By the left side, I'll just get 2x plus 6. The right side, I'll get x minus 1. I'm going to do the square roots times each other. Then 2 square roots of x minus 1 plus 2 square roots of x minus 1 is plus 4 square roots of x minus 1. And 2 times 2 is 4. Then I will subtract x, which will give me x on the left, plus 6, and I'll combine my like terms to give me 4 square roots of x minus 1 plus 3, and I'll also subtract 3. So I'll get x plus 3 is equal to 4 times the square root of x minus 1, and then I'll square each side of the equation again. The left side of my equation will give me x squared plus 6x plus 9 is equal to 16 times x minus 1. Distributing the 16, I get x squared plus 6x plus 9 is equal to 16x minus 16, which, moving everything to the left side of my equation, gives me x squared minus 10x plus 25, which is a perfect square trinomial, which is just x minus 5 times x minus 5. So my solution is x equals 5. So we only get one solution this time, but we need to make sure it works. So let's check it. So checking the solution, I'll have the square root of 2 times 5 plus 6, which is square root of 16, minus the square root of 5 minus 1, which is 4. So 4 minus 2, when I take the square roots, is 2. So that does work as a solution. And that is how you solve an equation with two radicals.